Okay, we're going to do a quick walkthrough of this test so that you have the information that you need. So when we're looking at the volume of just the flesh, so here is our radius. Okay, so we're going to call this R. Just from here to here is R. And it says that the flesh extends, the seed cavity is about half the radius of the fruit flesh. So this whole thing here is 2R. So if this whole thing, if I'd said this was R, then this would be half R. But I am going to avoid fractions by turning it around the other way. This is R, and this whole thing is 2R. So our algorithm here would be the volume of the whole thing, so the volume of the big whole cantaloupe, minus the volume of the small sphere, which is the seed cavity, divided by the whole thing, times 100% is going to be our percentage. So, volume of a sphere is 4/3 pi. Now, R in this case is 2R, so it's 2R cubed minus 4/3 pi R cubed over 4/3 pi 2R cubed. Now, this is the key, is making sure that you understand that that 2 is part of this big R radius, okay, because it's twice this smaller one. Notice that I have here a 4/3 in every single term, a pi in every single term. So now I'm going to resolve this a little bit. Okay, so I have 2 cubed is 8, 8R cubed minus, well, this is just R cubed. And then I have 2 cubed R cubed, so that's 8R cubed. So there's an R cubed in every single term, so it cancels out. So I've got 8 minus 1, because that's that implied coefficient here, over 8. So that's 7 over 8 times 100%. That comes out to the nearest tenth to be 87.5%. I know I worked this one out on the board, but let's look at the way we work it. The total is equal to the volume of the cone plus the volume of the cylinder plus the volume of the hemisphere. Okay. So let's look at our picture here. If this is radius, and that's a 45-degree angle, and I'm sorry, get a shadow here because it's dark in my room. That means that this is also R, because this is a 45, 45, 90 triangle. Okay, so the height of the cone is R. Okay, this height of the cylinder is 2R, and the radius of the hemisphere is R. So all we need to do is remember our formulas. Well, the volume of a cone is 1/3 pi R cubed. I'm sorry, that is the cylinder. That is the hemisphere. Okay, volume of the cone is 1/3 pi R squared, that's the base, times the height, which is R. Volume of the cylinder is the area of the base, pi R squared, times the height. In this case, it's 2R. The volume of the hemisphere, well, the sphere is 4/3 pi R cubed, so this is 2/3 pi R cubed. Okay. Now, we see a pi in every single term, but we're not going to cancel it. We're not dividing everything by pi because we'd have to divide the left-hand side by pi as well, and we're not interested in volume over pi. But what is R squared times R? Well, that's R cubed. So we have 1/3 pi R cubed plus, let's bring this 2 out in front, 2 pi. Well, we've got another R squared times R, which is R cubed, plus 2/3 pi R cubed. Well, look here. I got a 1/3 and I got a 2/3. Well, 1/3 plus 2/3 is 1. So that's 1 pi R cubed between these two terms, plus 2 pi R cubed, which is 3 pi R cubed. That is your total volume. Okay. here's our frustum. There's a couple of different ways to do this, but this is the way we talked about in class. Okay. So when I look first, this is my slant height. It's clearly shown as slant height. I need to find the height here. So I've got this little triangle, that this is 5, and this part, so when we cut off this 3 inches here, what's left is another 3 inches. So this part is 3. And I can use this, we're going to call this height 1. I can use the Pythagorean theorem to figure out, well, 25 minus 9 is 16, and the square root of 16 is 4. Now I'm going to look at the whole thing. Let's put a ghost cone on top of it. Okay. So I determined that this was 4, and this is 6. I know this is 3, and I want to find this other height here, the ghost cone that I'm setting on top of this. Well, I can set up a proportion because I have similar triangles. I can say that the base of this one over the height of this one is equal to the base of this one over the height of the whole thing, which is h2 plus 4. It's not just 4, it's the whole triangle, similar triangles. So I have 6h2 is equal to 3h2 plus 12. Subtract 3 from both sides, I get 3h2 is equal to 12. And then I get my second height is equal to 4 as well. So what I've got is another cone on top of here that's also 4. So that whole thing is 8. Okay. So the volume of the frustum is the whole volume minus that small top cone. Okay. So let's get the whole volume. Our whole volume of cone is 1/3 pi r, in this case is 6 squared, times the height. Well, the height of the whole thing is 8. Minus our top little cone. Well, it's also a cone, 1/3 pi. In this case, r is 3 squared, and the height of this top part is just 4. Okay. All right. I'm going to take out my 1/3 pi out of each one and deal just with this part for each one. Well, 6 squared is 36. 36 times 8 is 288. 9 times 4 is 36. So I get 1/3 pi times 84. Sorry, not 84. 288 minus 36. Get out a handy dandy calculator. 288 minus 36 is 252. And then I divide that by 3, and I get 84 pi inches cubed. Okay, because remember, this is inches times inches, then times inches. Okay, I know this looks different than yours. This is my copy of it, and I don't need nearly as much space as I give you guys. Okay, I've got an octagonal pyramid. Okay. I know that the volume of a pyramid is 1/3 the area of the base times the height of the pyramid. So the first thing I've got to do is figure out the area of a base. I've got an octagon, and so when I take 1/2 of one side, so here's the one side, remember that this here is 360 divided by 8, which is 45. So this little half is 22.5 degrees. I'm also given that the apothem is 4. So I've got that is 4 centimeters. What I need is to find, because we know about the regular polygon, the base, the area of the base would be equal to 1/2 the apothem times the perimeter. So I know my perimeter is the number of sides times the length of one side. Okay. So I'm getting all those little triangles and adding them all up. Well, this is easy because this is I'm gonna call it x. X is equal to 1/2 of a side. So a side is 2x. But I can find x pretty easily here because I can use right triangle trigonometry. And I know that the tangent of 22.5 is equal to the opposite over the adjacent. So I've got x is equal to 4 tangent 22.5. So the side length is equal to twice that. So that's 8 tangent 22.5. And I know that my perimeter is going to be 8 times that, which is 64 tangent 22.5. So area of the base, so we're going to call it big B, is equal to 1/2 the apothem, which is 4, times the perimeter, which is 64 tan 22.5. Well, 1/2 of 4 is 2. 2 times 64 is 128 tangent 22.5. Now, I'm not even going to resolve that. I'm not going to spend my time doing that because it just goes up into this formula. So I've got volume is equal to 1/3 of 128 tangent 22.5. And then it says the height is 12. All right. So, well, we can do 1/3 of 128. But that's not a nice even number. But 1/3 of 12 is 4. So 128 times 4 is 512 tangent 22.5 degrees. Now that would be exact, but it asked me for the volume, and I think yours says to the nearest thousandth. So my volume, when I put this into my calculator, is going to be, let's look, 512 times tangent of 22.5. Okay, so I've got this nice number here, 212.0773. So my volume is approximately equal to 212.077 centimeters cubed. Okay. I don't remember if I left this as a hundredth or not, but that would be 212.08. This one most people got, but, I'll show you how I looked at it. Okay, I cut off this top part. The volume of that one is the area of our base, and we're going to say this is a 10, area of base, 10 by 12. And the depth of this, the height of this little pool that we're looking at is 2. So that's 120 times 2, which is 2. No, I wrote in 12. I wrote in 12. 10 by 8, because I'm doing just this portion. 10 times 8 is 80, times 2 is 160. Okay. And now we're going to do this little bottom part. Okay. Now it is 3 by whatever 12 minus 8 is, because it's just this distance here. So this was 8, so this is 4. So it's 3 by 4, and it's still a depth of 2. Okay, 3 times 4 is 12. 12 times 2 is 24. So the total is equal to 184 centimeters cubed. Okay. And the last one on this video, the volume of the cylinder is 96 cubic meters. Height is 6 meters. Find the length of the diameter of this cylinder. So let's look here what we've got. This is 6 meters, and our volume is 96 meters cubed. Well, volume of a cylinder is the area of the base times the height. Area of the base of a cylinder is pi r squared, then times the height. So let's fill in for volume. 96 is equal to pi, and we don't know what r is, so r squared, but the height is 6. 96 divided by 6 pi, well, let's do 96 divided by 6. Well, that is 16. And we'll divide it by pi to get r squared. This is fine, but we're not looking for the radius, we're looking for the diameter. So let's take the square root of both sides. Well, this is the square root of 16 over the square root of pi is equal to r. Well, the square root of 16 is 4. So that's 4 over the square root of pi is equal to r. And again, I could resolve this now, but I don't need to. I know that diameter is 2 times the radius. So my diameter is 2 times 4 over the square root of pi. Well, that's equal to 8 over the square root of pi. Okay. And yes, I could then multiply by root pi over root pi, but I'm being asked for the approximate length, so I can just plug this in my calculator. Okay. 8 divided by the square root of pi, 8 divided by square root of pi is equal to 4.5135, which when we round it properly is 4.514 meters, just plain, because it's a length. It's just the length. Okay, come back with the second half.